Hello and welcome. I'm going to be talking about pattern matching in Elixir, which is a really cool thing. You can kind of see aspects of it in other languages. Some languages have more of it, some just have this like tiny part, and some don't have anything at all. Um, I think it's mostly a fairly intuitive feature, but there are some gotchas that you can run into. But if I have time, I'm going to go into that as well. I will be live coding the whole thing. I just have a cheat sheet here to remember so I don't miss anything. But the idea is that I'm going to be mistyping constantly for 20 minutes. All right, so let's start with, I think it's best to start with the match operator. So in most languages, if you type something like this is assignment, right? And that's true for Elixir too. But the equals sign here, called the match operator, does a lot more than just assigning things. Um, oh, and Elixir does have reassignment, which is different from Erlang. Doesn't allow this. Uh, this is not the same as mutating. It's just reassigning it. It doesn't change anything. It's just saying that, it used to be this. It's now pointing to another thing. But okay, so let's go into why the match operator is different from the assignment operator in most languages. One thing we can do is we can switch the operands here. Now, in most languages, this would just be an error, right? In Elixir, this means that what is on the left side has to be matched by what is on the right side. So this fits into the assignment, because if we have some variable that's not defined on the left side and we put something on the right side, then that matches and we can assign. It kind of makes sense. But if you're putting something on the left side that is a thing, then what you put on the right side has to match that thing. And there's a lot of use cases for this. So let's define a function. And this is a pattern that a more advanced version of this is what you'll see in a lot of places where people use Elixir. So I defined an anonymous function here. I can call it like this, and I get OK back. Now, a lot of functions, a lot of things in Elixir will return OK or a tuple of OK in something. This is a very common pattern. And one thing we can do is we can assign what we get back from the function. And now A is OK. We can also type OK directly here, call the function, and it's OK. This is fine. But what happens if we put something else on the left side? We get an error. And this, what this is so I think the way to look at pattern matching in Elixir is that it's actually a bunch of different things. With the match operator, you have assignment, but now you have this. This is something different. And this is this is an assertion. We're saying that what's on the right side has to be like what I'm writing on the left side. So we can require that our data has a certain shape. And this follows like the basic, if the function returns error and you get that pattern, this works the same way. And we can do like really simple, okay, that of course doesn't match. So let's move on. We also have a match anything symbol, I guess is the word for it, which is very useful in other cases. You can also name the match anything symbol. It doesn't really do anything. It doesn't assign a variable or anything. It's just, this is mostly something you use when you write code to document what the thing you don't care about is. And you can use this operator multiple times. You can do OK equals OK equals OK. It will just apply from the right. So let's move on. Let's look at more interesting things. This is really basic, right? This is just explaining this is the pattern we use, and then we can move on and we can put different things on the left side. Oh, sorry, yeah. Oh, sorry, yeah. So I was going to ask you from the start to point out or like ask me if I'm assuming any knowledge because I don't want to do that. This in Elixir is called an atom. It is a unique value that is just itself. It's useful for defining constants basically, and you'll see it everywhere in Elixir code. They just evaluate to themselves. But yeah, moving on to lists. We can pattern match or on lists as well. If we put an empty list on the left side and put a list with one item on the right side, it doesn't match. And we can do this with basically any size list. Although I guess it gets awkward after a while. But then moving on to the next part of pattern matching. So we've talked about, we've got assignment with the match operator. We've got assertions where we require our data to have a certain shape. We can also combine these and use what is commonly known as destructuring. So if you're familiar with JavaScript, and you've used modern versions of JavaScript, you've seen destructuring, where you can define, like you have an object on the left side, you say you have these keys, and I want them to be assigned to these variables. It's a really nice shorthand for like grabbing specific things out of an object. And we can do the same thing in Elixir. We can say that we want we want the thing to be a list of one item, and we want that one item to be assigned to A. And now A is 1. And this, of course, you can do this with 2 items, etc. Now, sometimes you don't care what the size of the list is. You just want the first item of a list. And there's a pattern for this. So, I'm sorry, I just realized that everything is always like at the bottom right side of the screen. I'm sorry about that. So the pipe character here says that everything on the right of it is the rest. And in this case, we put an underscore there. We don't care about the rest. So we got the first value and the rest. We can assign to the rest as well, and rest will be 2, 3. There's finally sort of a this sort of brings this sort of funny looking pattern where you can match against a list that has at least one item, because this says that it has to be one item, but I don't care what it is, and there has to be a rest, but a rest can be empty. So it'll match even if I put some matches. It has many names. So let's move on to maps. Maps are a very common data structure in Elixir. Map will match itself. A map also matches, and the empty map also matches a map with things. So this is different from how lists work, and it's basically the idea is that you have cases where you want to match against an empty list. Maybe you're reducing over what's the word? Well, you're working with some list. You keep shaving items off of it, and you want to know when you're done, when you have the empty list. So you need to know. You need to be able to pattern match against the empty list. You don't really have the same thing with maps. You're rarely in that same situation. So they decided to go a different way with maps. So with maps, you can instead say that it should be a map. It doesn't matter what items it has. It doesn't matter what keys it has. It just has to be a map. And you can do assignment in a map as well. And now A is the string A. Does that make sense to everyone? And you can, now this is going to be a lot of typing. I'm gonna try to make it short. You can do nested destructuring as well. Almost there. So this says that so the pattern we want to match on the left has the key A with the nested map with the key B that has a string B, and we put the same thing on the right that matches. If we put something else on the right, it doesn't match, and we can also, of course, assign whatever is in here. C is B. So this of course is very familiar if you use JavaScript. This is exactly the way JavaScript looks. But you don't really have the same like in Elixir, you can combine the two things. You can make an assertion. You can say that it has to have one key that has to have the certain value, and then I want to get what the other key is. So you can go further. I'm gonna just go ahead and show. So this was a map using atoms as key, since we briefly talked about atoms. If you want to use a map that has strings as keys, this is the pattern you use. So there's an arrow instead. Significant little difference. Now, how am I doing for time, by the way? Nobody knows. Oh, I'm gonna do some typing. Listen, oh, def module. Oh, thanks. Yeah, def struct. So I defined a module and a struct. So do people know what structs are? Generally have an idea. So they're kind of like maps, but you can define what keys they should have. It's a really short and simple answer. You can also pattern match against structs. So we can say that, okay, so we have something that is a person. We want to make sure that it is a person. And if I put anything else here, even if it has a name, that's what you say, it doesn't match. But the opposite is not true. So if you have if you have a struct, it is a map, but a map is not a struct. And this works the same way as matching on maps. You can grab things out of it, and you get a string. And you can of course combine these. You can nest and put all kinds of levels of lists and maps, and oh, I didn't even mention tuples. Okay, and result is a pretty common pattern. This is something you'll see in a lot of places. So you call some function and it returns okay and result. So on the left we have some form of data. This is like one of the most common patterns you'll see, because in Elixir you frequently want to return data that is either some kind of a successful result or an error. And this is where this is one of the places where pattern matching really shines, because you can easily define conditions where, okay, so if it is an okay, I get the value, but if it's an error, I want to maybe report the error. And then I have my final data type that I want to talk about, and this is one of the more like special ones. So a binary matches itself, but it also matches the syntax, and this works both ways, because for lots of historical reasons, Elixir strings are also called binaries, and they are binaries. There's two types of these binaries. There's the actual binaries that are each each like part, it's evenly divisible by 8. So it's bytes. It's a byte list kind of thing. Um, and then you can have bit lists where your bytes might not actually, or the pieces might not actually be bytes. You can have like 6 uh, bits instead. And I'm gonna show you a couple of examples. We can match, like this matches anything. But this requires there to be 2 characters. And each character here is 8 bytes. Um, yeah. Uh, yes. That is a bit list, which is a binary that Elixir doesn't know how to represent it as characters because it's not like valid UTF-8, something that you want to read. So it represents it like this. Yeah, yeah. And you can get this like you can get this opposite thing too, where you use a character list, right? And you put in a bunch of numbers in a list, and it gives you characters back. So I think if I do, yeah, a lot of it is from Erlang. Yeah, it's like mm. Yeah, you have this here where I did a list of a single number 32, and Elixir or IEX helpfully tells me that that's a space. Um, we can grab pieces. So let's go back to the binaries. We can grab pieces of a binary. So let's say I just want the 4 first bits. Actually, I think I have to. No, it's fine. This doesn't match because what's on the right side is 8 bits. But then if I say I don't really care about the rest. No, wait, I have to say size 4 for this too. Binary. Oh, okay, yeah, cool, cool. Um, so I say I want the first 4 bits, and I don't care about the second 4 bits, and that's a 6. So this isn't something that I use a lot of, but it's a really cool concept, I think. Right. Yeah, it's one of the strengths of Elixir. Really, is this sort of idea that strings are binaries, and you can split and grab and uh, get pieces of it and work with it directly, which means you can pattern match on it directly, which means you can write these really efficient function signatures where you say like I'm only interested in this part and this part and this part of some input, and it makes I think it makes Erlang and Elixir more performant than it should be in a lot of cases, which is pretty cool. Um, oh, and I'm gonna show you. I have like one. This is really the last one. Yeah, there's this syntax for. Let me just do this first. This is just concatenating strings, and you can do that in when you're pattern matching as well. So this matches this. So a lot of what I've been talking about isn't really um, might not seem super useful because let's say that okay, I want to handle I get an okay back, and then I want to do something. I get state, and then get something. Oh, but it actually returned an error, and my process crashed. this isn't necessarily what you're looking for, right? So what you most commonly, I think, use this for is actually in function signatures, where it works pretty much the same as with the match operator. Whatever you put in your function signature, so you can define a function. This is really awkward to do in the in IEX, but okay. So I'm just going to type it out. But if you define a function and you say, oh, but I'm only interested in some kind of map, then this function clause will only execute if it's passed a map. If I pass it something else, it will either say that there's no clause, or maybe you define another clause and it will work. But this part is really hard to do in IEX because you have to define a module too. That's pretty much it. That's what I had for pattern matching. Thank you.